Welcome again to Initiative Math class. Today I'll be introducing you to binomial theorem. And the question here is, find a term independent of x in the binomial expansion 2x minus 1 out of x squared all to the power 9. Here the technical term that one needs to understand is the word independent. Independent. Find a term independent of x. If I have 2x, if I write 2x like this, this 2x depends on x. But if I write 4, this 4 is independent of x. That is, it does not depend on x. It does not change with x. So one thing that is clear about this is that any term that is independent of x is the same as 5x to the power 0. In other words, if I have 5x to the power 0, it's the same as 5. If I have 4x to the power 0, it's the same as 4. That means this particular term is independent of x. So that is the meaning. So to be able to find a term that is independent of x, we need to find the general term of this expansion. And that is, if I have, for instance, if I have a plus b all to the power n, this is equal to n combination r, a to the power n minus r, b to the power r. So if I have a plus b all to the power n combination r, a to the power n minus b to the power r, this expansion gives us this general term. This is the formula. And so if I have 2x minus 1 out of x squared all to the power 9, our n here becomes 9, our a here becomes 2x, and our b here becomes negative 1 out of x squared. And so this one turns to 9 combination r, 2x to the power 9 minus r, and our b here is negative 1 out of x squared. That is negative 1 out of x squared all to the power r, according to the formula. The next thing for us to do is to simplify this expression. So let's see how the simplification is done. This one is equal to 9 combination r, 2x to the power 9 minus r. In indices, let me do this demonstration. In indices, if I have 2x to the power 9 minus r, this one becomes 2 to the power 9 minus r, and then x to the power 9 minus r. So the expression here becomes 2 to the power 9 minus r, and then x to the power 9 minus r. Then this one also becomes negative 1 x to the power negative 2 all to the power r. Again, in indices, if I have 1 on a to the power n, this one becomes a to the power minus n. That is, if a to the power n becomes the numerator, then the power n changes to negative. So here, the power which is 2 becomes negative here. Again, if I have, for instance, a dot b all to the power n, this n will affect a and it also affects b. So the a will take the power n and the b will also take the power n. I apply the same principle here. And so the next stage, it becomes 9 combination r, 2 to the power 9 minus r, x to the power 9 minus r, then negative 1 to the power r, this negative 1 will take the power r, and then negative 2 multiply this, and I'll have x to the power negative 2r r. So the expression reduces to this one. Now the next thing is, I need to make sure that I decompose or bring all the x components together. That is, from the same indices, if I have a to the power m times a to the power n is a to the power m plus n. I take one of the base and then add the exponent. So this one again reduces to 9 to the power r, 2 to the power 9 minus r, and then x. I will take one of the base and then add the exponent, giving me x to the power 9 minus 3r. Then I will have my negative 1 to the power r here. So this expression has reduced to this one. Now I need to separate all the x components here and then separate all the other components. And so I'll be having 9 combination r, then this negative 1r will appear here, followed by 2 to the power 9 minus r, and then I'll have my x here to be x to the power 9 minus 3r. But remember we stated that we are to find a term that is independent of x. So any term that is independent of x has its exponent to be 0. It has its exponent to be 0. That means I need to equate the exponent of x to 0, and that will give me 9 minus 3r to be equal to 0. That is negative 3r is equal to negative 9. And r will be equal to positive 3 by dividing both sides by negative 3. Now, because I am to find the term that is independent of x, and the term that is independent of x has the power to be 0, it led me to get the value of r to be 3. And so I need to find this particular expression, the answer for this particular expression, because this x here will be equal to 1 when the power is 0. My focus now is to find this expression. 9 combination 3 because r is 3, minus 1 to the power 3, and then 2 to the power 6. With this expression, I'll be having minus 5, 3, 7, 6. By using your calculator, this should be the answer. So the term that is independent of x is minus 5, 3, 7, 6. So that is all for this particular question. The term that is independent of x is negative 5, 3, 7, 6. If you have any difficulty, you can hit the comment, and then the next video I'll try and then explain. God bless you so much for following. Thank you.